Alien. Okay, so we got a probe in deep space, like I said, infested with alien bugs, and it's going to be blown apart so that the aliens, they perish in space. We know the spacecraft is at rest, so it has an initial momentum of 0. Okay, so our initial momentum is 0 here. And then when it blows up, we have 2 pieces of the craft. The first piece of the craft, kind of draw this, has a very large mass, 6 times 10 to the 8th. And if you're on a calculator, I like to write this 6e to the 8th on a calculator. And it's going one direction, which we call positive. I guess this is positive, no worries. At 210 meters per second, so that's a velocity. And the second piece here on the other side, we don't know the mass of it. Oh, no, we do know the mass of it. It's 1 times 10 to the 8th. But we don't know the second velocity. And that's what we're looking for after the explosion. So how can we set this up? Well, we are saying that the initial momentums equal the final momentums here. And initially, because we were at rest, our initial momentum was 0. And our final momentums are given by 2 objects. So we're going to add those together, and they should add up to 0. Since we know momentum is a mass times velocity, we can say that mv for the first object is that 6 times 10 to the 8th kilograms times a positive 210, because that's what we were given here. We said that was the positive direction. And for our second object, when we add it, we have the second mass, 1 times 10 to the 8th kilograms, and then some unknown v2, which, if it's going in the opposite direction, it should be negative. We should get a negative number for it, but we're not going to put the negative in the problem. It hopefully will come out to be negative, okay? So, if I want to solve this, I just need to solve for v2 here. And however you like to do that algebra, that's totally up to you. I'm going to show you a kind of neat trick that I like to do and employ to make this problem a lot easier on the calculator. So I'm going to recognize that 6 times 10 to the 8th times 210, I could multiply those together right now, and I'd get a number. And then I'd have to subtract that number over to the left-hand side of this problem. I'd have to, take whatever number I get, and I'd have to bring it over. So it'd be a negative number. Well, instead of doing that, what I'm going to do is I am just going to bring the negative of 6 times 10 to the 8th multiplied by 210. That is some number there, and I brought it over because it's now negative. And this will equal 1 times 10 to the 8th multiplied by v2f. That's that final velocity we're looking for of the second object. Now, you might be looking at this like, why didn't you just multiply those together? That was an easy thing to do. Well, sometimes I don't have a nice fancy calculator sitting around. Sometimes I have my phone, which has a garbage calculator on it, or maybe I'm just sitting on a beach, deserted, and just working out physics by myself. I don't know. But what I can do here is if I divide by 1 times 10 to the 8th on each side, because that's my next mathematical move, when I divide by 1 times 10 to the 8th kilograms, the kilograms here and the kilograms above are both times 10 to the 8th. And that just means there's 8 more zeros on each of these. Well, if you ever recall, if you did something like 100 divided by 10, a neat little trick you may have learned is that you could just get rid of trailing zeros because they'll divide out or they'll cancel. Which means that all 8 of the zeros in the denominator and all 8 of these zeros in the numerator are going to divide out. So this problem quickly becomes for me just negative 6, or negative quantity 6, times 210 equals v2f. Because my denominator here is only a 1, I'm not even going to write it. And I can just go to my calculator, say, what's 6 times 210? It gives me 1260. And I know that's a negative value because it's moving in that negative direction as we designated in the problem. So that gives us our final answer for not only the direction, but the magnitude of that second piece. And if you did multiply the 6 times 10 to the 8th and the 210 together and then subtract and then divide, that will still give you the exact same answer. I just showed you a little trick there to get rid of those pesky zeros and make life a little bit easier for you. Okay? So with that, this separation problem for the conservation of momentum is finished. We've got one more to do. We're going to look at a kickback from a rifle in the next one. But until then, adios, and take it easy.